Problem 63 asks us to prove this trig identity. As a general rule of thumb, we'll choose to simplify the side of the equation that has more terms. In this case, the left side of the equation has 2 and the right side has 1. Another rule of thumb would say we should simplify the side that has more trig functions, and the left-hand side has 2. We'll start by converting tangents and cotangents into terms of sine and cosine, so that tangent of u becomes sine over cosine, and cotangent becomes cosine over sine. When we're done with this, we'll focus for just a moment on the numerator of this large fraction. We can see from those two fractions being subtracted that a common denominator will be sine of u times cosine of u. So we'll need to multiply each one of those fractions. For example, the upper left-hand fraction of sine over cosine would need to get multiplied by sine on top and on bottom in order to get a common denominator of sine of u times cosine of u. We end up with sine squared of u minus cosine squared of u over sine of u times cosine of u. We'll follow a similar pattern in the denominator. Again, here the common denominator can be sine times cosine. So for example, we multiply that first equation, the numerator and denominator, by sine in order to make them match up. Now we look at these two fractions, the numerator and denominator, and realize we can cancel out the sine of u times cosine of u, because we would just end up multiplying by the reciprocal of that denominator. As a result, we have sine squared of u minus cosine squared of u, and in the denominator, sine squared plus cosine squared, which is a commonly known identity that's just equal to 1. Therefore, we no longer have any fractions in this problem. What remains is sine squared of u minus cosine squared of u plus 1. If we think about turning around that identity of sine squared plus cosine squared equals 1, we could rewrite this as sine squared minus, and then replace the cosine squared as being 1 minus sine squared. Then if we distribute that negative through the parentheses and combine the like terms that result, we get 2 times sine squared of u minus 1 and plus 1, which simplifies to just 2 times the sine squared of u. This is what the right-hand side also was, and so we have proved this identity.